do you use the principles that we looked at on calculating the resultant force? How do you use those principles to determine an unknown force if they give you an unknown force? So here is a question. Three forces shown in figure 2 below are in equilibrium in the same plane. Then normally the question says determine the magnitude of P and Q, because these two you're going to have to do anyway, even if they don't ask for. So yeah, they did ask just to give you free marks, but the main question here is that determine the magnitude of P and Q. Okay, so let's get started. So once you have it, the next step is for you to get the components of force P and force Q, because 500 is already horizontal. So you leave it like that, but you're going to have the vertical component of force P and the horizontal component of force P, a vertical component of force Q and a horizontal component of force Q. So you see that force P is going more upward and more to the right. Hence, the components are going right as well as to the upward direction. So force Q is going more to the right and more down. So the component will go downward and the horizontal one will go to the right. Okay, that's how you determine your directions. So let me just re-sketch it so we can see it clearly. So just before we go there, this horizontal component of force Q is going to be Q cos 30. And then the horizontal component of force P is going to be P cos 30. That one is going to be P sine 30. And here is going to be Q sine 30. Okay, so let's just re-sketch it so that we can see more clear. So we've got a 500 Newton force here, 500 Newtons. And then this way we can have the horizontal component of force P, which is P cos, this is 45 this year. Made a mistake because the angle of P is 45. So that is 45 degrees also. P cos 45, and then for force Q, we're going to have Q cos 30. And then vertically, we've got an upward component there of P sine 45, that one. And then we're going to have a downward component here of Q sine 30, this one. Okay. Then the procedure says that sum of the horizontal components are equal to 0. The reason they are equal to 0 is because eastwards forces are equal to westwards forces. Okay. So if we apply that, we can say 0 is equal to P cos 45 is positive because it's going east, and Q cos 30 is also positive. It's going east, but minus 500 because 500 is going west. So if we rearrange it, we can say 500 equals to P cos 45 plus Q cos 30 to have everyone positive. So this we can take as equation 1. Then if we look at the vertical components, they are also equal to 0 because upward forces are equal to downward forces, because this is an equilibrium. And then we will say upward P sine 45, this one, that component, minus Q sine 30, this component. If we rearrange it to have everyone positive, we're going to bring Q sine theta to the side equals 2B cos 45. So this one, we can make Q subject of the formula by dividing by sine theta both sides. So Q will be equal to, that will cancel that, will be equal to, now what is cos 45 divided by sine 30? Cos 45 divided by sine 30. It gives us 1.414 P, that P. This P over here. So this whole part here is 1.414. Okay. So we can say this is equation 2. Then next thing we're going to do, we're going to substitute equation 2 onto equation 1. So equation 1 says 500 equals 2 B cos 45 plus Q cos 30. As Q cos 30. So Q is 1.414 P. So that multiplied by cos 30. So this is replacing that Q we have over there. This whole expression is replacing Q because Q is that. Then we just do the maths now. 500 equals 2. What is cos 45? 0.707 P plus what is 1.414 times cos 30? 1.414 times by cos 30. It gives us 1.225 B. Okay. Then we do the maths. We add up the 1.225. 1.225 plus 0.707 gives us 1.932 B, and the here we have 500, so it's 500 divided by 1.932. It gives us a P of 258.799 newtons. Now, once we have P, we can go back to that expression to get Q, because Q equals to 1.414 B, and B is 258.799. So this answer multiplied by 1.414. It gives us 365.942. Okay. So once we got B, we went back to this expression to find Q. So that's also in newtons. So that is how you would calculate an unknown force. If the directions are given, it's just the magnitude that is not known. You do your horizontal components, you do your vertical components, and then you get the final answer. Okay, so that part is done.